Hello, everybody. Welcome to another episode of the Index podcast, where the three of us come together every couple of weeks to discuss on-chain data, chart crimes, and metrics that move the crypto industry. And today we have a very special guest here, Thomas, head wizard at the Ethereum Foundation. And my other co-hosts, of course, are Denning, on-chain corgi at Flashbots, Hildobby, resident data house elf at Dragonfly, and I am Boxer, and I am the community powerhouse at Dune. Before we get started, nothing we say here should be relied upon as legal, financial, crypto, or even life advice. We are acting independently of our respective professional roles here. And with that, hello again, Thomas. For the listeners, Thomas and me were actually colleagues in a past life. So Thomas worked at Dune a while back. But now, Thomas, you're at the Ethereum Foundation, and maybe you could quickly kind of tell us what do you do there and what actually do researchers do?
Well, the EP is structured in teams. So I'm part of the Robust Incentives Group, or RIG, which is mostly focused on crypto economics, game theory, mechanism design around the protocol. So I joined that particular team. There are many other teams. There is cryptography team, consensus and R&D team. So there are many different teams. I joined that RIG, and what I did at first is coming in from a data angle, I guess, which was also related to my past Dune experience and some of the stuff I did during my PhD too. But I worked closer to data at first, and with a big focus, I guess, on MEV and PBS. But then I started to shift my interest a bit more towards consensus and a bit of more of a protocol design approach. And now, my time is basically usually split between collaborations with academia, and we write papers, and the other part is much closer to protocol upgrades. How can we take research and actually turn it into something that's implementable and that can be part of the next fork on Ethereum. So there is this kind of dual tasks, which I like. And so for the latter part, I've been recently focused a lot on censorship resistance and inclusion lists, which we will talk about a lot today. But this part is much closer to the protocol upgrade part, because we spent a lot of time, me and other folks, on the research side of this. But now we feel we reached a point where we are kind of ready to try to push it and turn it into some specs and some EIPs and some actual implementations.
I see. And does the Robust Incentives Group, do you kind of have a mission statement? Can you summarize in 2 sentences what your goal as a group inside of the Ethereum Foundation would be?
Yeah, for sure. Yeah. So it's all about crypto economics, game theory, and mechanism design. Those are the 3 things we focus on. So originally everything that touches economics of the protocol, so issuance, but also rewards for all kind of tasks and duties that validators have to do. Everything that is in protocol and that touches incentives, that is the core of what we do. But we have a super varied and mixed background, and it goes from very data focused to theoretical papers. So it's quite broad in how we function. But the main topics I would say would be issuance, censorship resistance, and what we call block construction. So EPBS, execution auctions, execution tickets, staking, MEV. All of these are kind of the areas we focus on.
Okay, very interesting. And then I think for the listeners, your background in, I think, neuroscience is actually super interesting. So if you quickly want to walk us through how did you actually end up at the EF? Because researcher is such a kind of vague term, and it's everyone at the EF is kind of a researcher, and it's so weird. I don't know, looking at it from the outside, I'm always why is everyone at the EF and a researcher? So if you could maybe just share something about your background and how that kind of uniquely qualifies you for that role.
Yeah. So first thing is we're not that many There are not that many researchers at DEF. But yeah, for me, well, I did a PhD in computational neuroscience, which is, yeah, very far from crypto. But I was focusing on like a lot of network analysis. And I thought at the time when I was still doing my PhD, I thought, oh, what if I like take the tools I use, like graph theoretical metrics and stuff like this, and I apply that to blockchain networks instead of applying it to brain networks. That was kind of the original idea. And I started doing that on the side a bit, like in DAOs and like in multiple like random projects for a while. And I thought it was cool and interesting. And then I reached like the end of my PhD, and I was like, okay, so should I keep going in academia in neuroscience, or should I maybe like try something else? And I gave myself a year to just try something else and maybe go back to academia after. And that's when I applied to Dune actually. And so I was working at Dune for a while, like so very close to data and blockchain data, obviously. Which was great. But I did still miss the research part of it, quite a lot. Like actually, like, working with academics and like writing papers and like having a bit more like time to research and go back to some of the things that I was familiar with during my PhD. And so, yeah, and then, I joined DF, I applied, we talked with Barnaby, which is, the team leader of the Robust Incentives group. Not about hiring at first, but I saw his talks and I thought it was super cool. And then we got talking, and then a position opened, and I ended up working at DF.
Yeah, great. Thanks for sharing that background. I think from here on out, Denning, you're most qualified in kind of our classic. This is a continuation of the MEV series, so obviously Denning's the expert here. So take it away, Denning.
Yeah. So we started doing this PBS or MEV series of interview for like 4 episodes, and we feel like we couldn't finish it without a episode on censorship resistance. So really happy that you're here to help us to also crack down this concept that being talked by everyone. So my first question is, what does censorship resistance mean to you, or in general in a blockchain context? And same question to Box and Dobby as well. Like, what does that mean to you? Like, and also what does that mean in the different layer of the blockchain that we use, like to a user, to the apps, to RPC, builder, relay, validator?
For me, I guess like the basic definition of censorship resistance in a blockchain context is like the chain should be like neutral to transactions that come in to and they want to make it on chain, as long as they are like paying enough fees. There shouldn't really be any other considerations or opinions from the infrastructure, like from the chain, about what goes in or what doesn't go in. So yeah, I think basically it's like, as long as the transaction is paying enough fees, so on Ethereum it's like the base fee, then any pending transaction should make it on-chain eventually, without like other kind of considerations. And then I guess you can split it into 2 categories like that we actually use a lot for the blockchain context, which is strong and weak censorship resistance. Some strong censorship resistance is like, okay, a transaction is not able to make it on chain at all. And that's like really hard for it to happen. For example, on Ethereum, you need to have like all actors, like 100% of the validators, for example, not to want to include that particular transaction, which is very hard to do. And then the weak censorship resistance is like mostly what we're going to talk about, because it's like a bit like more what can happen in practice. And it's just about like one transaction that is censorable or being censored, makes it on chain, but after a consider like significant delay compared to like another transaction that wouldn't be censored. So that's like also like, I think, a useful distinction to make. Yeah. And then, okay, maybe one last distinction is you can like also distinguish between reasons you may want to censor a transaction. There could be like legislation or regulatory reasons, but also like economic reasons. I don't want that Oracle update to go through, or I realize I can play timing games or like kind of stack my block in a more efficient way if I don't include some transactions. So these are like very different categories, and somehow we are trying to capture all of it and make it resistant to most of the types of censorship that can happen.
So strong censorship resistant and weak censorship resistant sounds like a block level CR and a transaction level CR.
No, because strong censorship would mean like in any block, a transaction cannot make it on chain. Like, so it's over time. Like it's very, like, basically it doesn't go on chain. Weak is just like it goes in, but is delayed. So it's the distinction is not like block and transaction. It's more like whether it actually is ever able to make it on chain or if it's just delayed.
Right, I see. Yeah, I see. So I recall this like discussion where basically, if you have a set of different builders or different set of like validators, and they are like decentralized enough, and some are censoring, some are not. Some people argue that it's not a problem because the transaction can't always make it there; it's just delayed. Yeah, right. So that will fit the second concept. I see.
Yeah.
What about you guys, Box and Dobby?
I think to add on, like strong censorship resistance would be really bad, and then like a bad measure for like decentralized systems. It would be like one way to measure that it's not really as decentralized as maybe ideally it would be, unless it is something that is massively has massive consensus around in terms of censorship. That's always hard to assess, I guess. But ideally, anything could make it on chain. And now, soft censorship resistance is definitely a problem, but definitely not as big of a deal. But it can have some pretty big impacts, and I think it's definitely worth looking into and researching.
I think there's a lot of interesting questions and discussion space here. Is it like, should every transaction make it on chain? Should we censor hacks? Is that something like, how would you even recognize those hacks? I think, which jurisdiction is a blockchain under? Because like, I think the most kind of famous historical example of transactions being censored is transactions that were related to Tornado Cash. So like a lot of like, if you wanted to deposit something into Tornado Cash, a lot of, I think at the time it was still just miners. I think this was like pre-merge. So it should just have been miners. They were not picking up those transactions. And then I think for a time, builders were also censoring transactions related to like Tornado stuff. So I think there's like a lot of interesting questions here. And it's like, how do you solve this as a system? And then I think also like how do you model this game theoretically so that nobody is really kind of liable in like a judicial sense? So I don't know. I'm excited to dive into this. I think there's a lot of nuance to this, but in the end, it's like, if you want to do a transaction on the blockchain and you don't have like super malicious intent, and then it's like, okay, who decides what is the malicious intent? But in the end, like you should actually be able to have it included in the blockchain in a timely manner, if you're willing to pay the fees for that. But yeah, just a lot of questions for me. I hope we can answer some of them.
Yeah, I mean, the thing you said are kind of somewhat, conflicting with each other. Like, so as towards Thomas' definition, like it should be neutral and not have any opinion. So including even hacks, its code is law, and so like they should be passed through. But we would have a general consensus that it's bad for the ecosystem. And then another more specific example is what you mentioned as like OFAC sanction. And to just to clarify that for the audience, OFAC means Office of Foreign Assets Control, as I Googled. And so there are a few cases of like, what OFAC doesn't like. For example, when the Russia and Ukraine war started, there are many addresses like that's against Russia. There's also Tornado Cash example, as you say, which they are concerned about, like potentially people who are money laundering can use the Tornado Cash type of service to mix their funds and not be able to track and be basically regulated. So all these kind of things actually resulted in a lot of like heated discussion in the PBS community. And so yeah, I mean I think the definition Thomas had was like pretty clear. It's because it's like OFAC's opinion is also like a regional government level kind of opinion that they are against, but like, does Russia agree with that? I don't know, right? Like there are people who don't necessarily agree, so it's not quite neutral. Yeah, and specifically to some parties' interests. So I guess like another question, just to like finish the definition part, is like, why do we need to care about censorship resistance? It's a kind of ridiculous question. Like I mentioned this, I think before the recording, and Thomas laughed. And I think it's an obvious question that we care about censorship resistance for most of the Westerners. But to be honest, like I am a Chinese person. I grew up in China. Like growing up, unaware of all the opinions about like surveillance and censorship. Before I was 18 or before I got to abroad. I felt fine. Like I was whatever happy with like the cameras in the public place. I was like, it's a trade-off between like security and safety, and the government will not do anything towards me, who is a nobody. I changed my opinion afterwards, right? Because it's like, it's not about if they are doing something or did something to you in the past. It's like if they are able to. So I think, yeah, censorship resistance is important. It's also somewhat an ideological kind of topic, I guess, but I guess to you guys, like, why do we care about censorship resistance? Like, what's the worst case scenario that can happen if we don't have it? Like, there are also like a meme on Twitter where people say like, yeah, Ethereum haven't solved this, but have like World War III level like censorship resistance. So yeah, I wonder why EF researchers care so much about it.
So, okay, lots of cool, interesting things that were mentioned by you guys. I think, yeah, one of the things that you guys all touched on is like that censorship resistance in a blockchain context is like very rooted in decentralization. Like the best kind of way to prevent censorship in the first place is kind of, yeah, to have like a large number of independent parties that are like with different interests all around the world, and that are all participating in, and they all have a say in what should be included into blocks. And I think that's like the best way basically to prevent censorship. And then why should we care about censorship resistance? I mean, opinions will vary on this because everyone has like a different experience. But yeah, I think of it the other way around. Like, what's the worst case scenario? I kind of think of it like, what is the best case scenario? Best case scenario is like we can actually provide something that doesn't exist yet for, or at least I don't think it actually does exist yet, which is like a very robust, credible, credibly neutral, like permissionless, censorship resistant infrastructure that everyone can actually build on. So it would be, I think, like a very valuable if we can provide this as an alternative to like centralized service providers, which are great when they work. I don't think like, yeah, I actually don't think like censorship resistance is like super needed when you assume people you are trusting are like very well intentioned and like everything works as you intend. I think it can even be like faster or more efficient. Like it can be nice. When censorship resistance is crucial, it's like, yeah, when you don't have access to well-functioning services providers, or maybe you can't or don't want to trust them. So yeah, so I think like that's, yeah, I think of it of best case scenario rather than what can happen in the worst case.
I also think there's like, if you look at the way technology evolves, we don't really know necessarily what blockchain will be used for in 10 years. You know, what are going to be all the applications? We're starting to find a few like stablecoins and stuff like this, but it's constantly evolving and new things are coming on. So it would be kind of a like throttling factor if some people could be like, hey, we don't want you to bring this new thing on chain because we want to stick it to the old, pure way the blockchains were up to now. So I kind of think the lack of censorship kind of helps accelerate growth and discovery of new potential use cases of blockchains, which is, I think, one of the reasons I'm building in this space is like, the whole research aspect and what does it become? We don't really know, but let's experiment with it and let anyone do what they want on the blockchain, and we'll see what sticks around.
I think for me, one kind of prominent example that sticks out in my memory is there was a freedom convoy or something like that in Canada during COVID in 2021 or 2, I don't know, but somewhere during COVID. And the Canadian government actually just froze the bank accounts of those people. And it's like, that's pretty insane. And all the technology in our life has such a centralizing function that it's like, should the Canadian government be able to freeze the assets of people that just show like citizen, I don't know, like they descend from the government, but like they were not like looting places or like committing big crimes. So I don't know. I think that's like one thing where I'm like, okay, if we were like Ethereum, the government chain, or like if these networks were built in a manner where it's like, yeah, of course we're gonna listen to the governments and all the validators and all the builders and all of that, they need to adhere to all the different world governments, and it's like, okay, this is gonna really kind of limit the options of things that we're gonna do be able to do on chain. It's also like just a clusterfuck of legislature that you'll have to like pay attention to. So it's like, how can we actually design a system that just from the get-go kind of like makes it so that we don't have to think about all of these things, and that people can just actually keep self-custody of their assets and like, I don't know, USDC has a freeze function. It's like, how can we not have a freeze function on the entire blockchain due to kind of censorship that you could implement on a validator or on a builder level just by, I mean, the power of the different states. But yeah, it's going to be a long way there. But I think like that kind of like centralization of technology, and how do we fight back against those like centralizing forces where like they are kind of scary. I think that sticks out to me.
Yeah. Many examples probably in other countries, in other side of the world to mention. But yeah, I guess like to expand on blockchain specific context, and there was this one thing that SMG group did that kind of raised a lot of attention or awareness about censorship resistance. So SMG actually did some kind of performance art kind of thing where they basically built a builder and they built a block that has 0 transactions, and they bribed the proposer for 0.05 ETH only, and they got on chain. And it kind of makes sense because as of today, like Ethereum blocks value can vary like very fluctuately. And then like usually on average, the block can only just worth of like 0.02 ETH, which is like $50. So I think it made a lot of sense with the point he's trying to make, which is like, you see, like it's pretty easy and cheap to like censor, or you can say like halt the chain for like 12 seconds for one block. And if you want to do so, you can like do it for a much longer time with a fairly still manageable cost. So I think it raised some debate in the community. What do you guys think of this thing?
You said you can do it for like much longer for like negligible cost, but like for each block the cost is gonna rise because the block builder is gonna be like on the other side. I've got MEV proposals that are accumulating and growing. Maybe not exponentially, but like really, really big. And, the longer the holds, the more there's going to be discrepancies and arbitrage versus central exchanges. So there's this. And then there's also the fact that, like, what are the chances that SMG has another block, is lined up to propose the next block as well? So it's like, sorry, I'm getting confused. No, my bad.
You can bribe the big
yeah. They can bribe. But, like, what I mean is, like, bribery is going to rise to a point where eventually it doesn't make any economic sense unless you really have huge incentives to censor, and that's another topic, but I think it quickly has diminishing returns.
Yeah, that's a good point.
Yeah, I agree. If a huge MEV like spike arrives in the next block, then it becomes very, very costly to censor. But I think, the point was not really about like the cost itself. It was more about like the ease at which you can just like within the current infrastructure bribe someone to have your block included. And it was more about like, it was at the same time they released that paper about multiple proposals and censorship resistance. And they were basically saying we need to have multiple parties that get input into the block. So you need to bribe multiple people to actually censor transactions, which is something we will go back to because we have inclusion list designs that also involve like multiple parties.
I wish they would have done this for longer and actually ran the experiment. Like how hard can they make the chain stutter or halt the chain if they were to do this for like a continued period of time?
It
It's
really
kind of
depends on
sad.
the MEV opportunities, right?
Yeah, of course, but like I think like if you think about if I'm just sending DAI to someone, so like there's no priority fee, there's like a very low priority transaction, and then that transaction can just sit in the mempool for like a really really long time if somebody continuously kind of in between like the MEV profitable blocks where like the fee would be too high. Like if you would define something to like build any block with 0 transactions until like a cost of 0.05, then like you like in a day you can really like decrease the amount of transaction throughput that the chain would have, right? Because like there's only like in so many blocks there's MEV opportunities that get a bit higher than 0.05. I mean, in general, like it's very game theoretical because like if you do this more often, there would be more MEV opportunities that arise. So maybe the general payment, like I don't know, like where's the equilibrium? Like what's the real cost? So like I kind of wish that somebody would actually do this and just put it to the test to see what happens. But at the same time, like that. Like that would be quite the story. That would be a really interesting experiment to run, and also not cheap. But in the end, it's like if you don't like if your system doesn't survive like any malicious actor, then what are we even building here? So I don't know. I think this is super interesting that this is possible. I think this is like it's cool like in concept, but like it's really difficult to like make any kind of statements afterwards. It's just like, oh yeah, this is a proof of concept, but like what does this actually mean? Lots of implications to be explored.
Isn't like as impressive as it would be if you did it for a while, but I would love to see like simulation on, how expensive is it? And I would guess just due to price discrepancies in like sex test arbs, it would like fly into really, really high cost pretty quickly.
Yeah, exactly. I think if you so first like transactions accumulate, right? Like they keep stacking up, so all kinds of sandwiches and stuff like this also rises. You do miss a lot of sex arbitrage opportunities, so you have a lot of chances that the price actually deviates a lot from when the price stalled on the DEX. And it's going to fluctuate and going to go quite far from the price on the DEX. So I'm guessing like after a few blocks, like it will actually be quite hard to maintain this like low cost censorship for a few blocks in a row. We could definitely do simulations on this, but it doesn't sound very sustainable.
Yeah, but I mean, like following the logic you guys have, it still have a point where like it's probably worse for the chain without MEV, right? Like in a way, you could also argue that like the market volatility and like the user adoption, like the the level of activity, also provided some security for Ethereum because there will always be MEV coming. Yeah. Another example to put censorship resistance into blockchain context is the blob contention discussion, I guess. So like right after Duncan upgrade in March this year, Block Native was tweeting about the concern of like blob contention. It's a new word made up here, but basically it means like now that after Duncan upgrade, where L2 now is submitting their transaction confirmation to Ethereum L1 using the new data structure Blob rather than call data, which actually reduced the cost largely by 99%. But here's the thing, which is like it's fairly cheap transaction, but also takes a lot of like data sites for block builders to pack into the block. So the implication is that when the block builder build a block and they include blobs, who are actually fairly large data sides in terms of the total sides, when they send it to Relay, it will likely take slightly longer and more time cost for a Relay to load the block content and try to do whatever simulation or validation. So then there is this concern that like the block builder who are highly economically incentivized or driven, they will try to avoid blobs transactions, which effectively is causing censorship towards L2 transactions. So then they were tweeting about like at a high demand time of transaction, the contention was up to like 300% plus, which is basically, I would say, like a market dynamics by nature. It's like when the market is so volatile and there's so many high value MEV transactions, they pay so much high gas priority fee. Compared to them, the L2 blobs gas is much lower. And sometimes I think you could argue block builder is not like really intentionally censoring them or dropping them out. It's just like low value transactions, like a value transfer. It has to wait in mempool as a pending transaction. Following the discussion, I was looking at this dashboard. I built this dashboard and looking at these metrics, where I was looking at basically for each builder breakdown, how many blobs do they have in their blocks as like a percentage, like what's the blob concentration for different builder. I did notice that I think some of the top strategical builders, they were censoring the blobs didn't have blobs in their blocks for a bit. Titan was not including blobs, but more because of a bug in the beginning. They started having blobs a few days after they fixed the bug. Penguin Builder was one of them, obvious one that didn't include blobs. For a while, it was like 0% here. I think the current situation looks generally healthy, where the top two builder, Beaver and Titan, who are making up to 80+% market share, both have like a 60%-ish blob percentage, and as also most of the other top builders. I don't know if you guys have any opinion about this blob censorship concern, or what's the current status quo of, like, how is this debate settled?
Yeah, no, I think it's very important that we find some good solutions for including blobs as well. And there are like some proposals we are already working on to have inclusion lists work with blobs. At the limit, I think it's exactly what I was talking about when I was talking about economic censorship, right? Because it's basically, okay, you want to exclude whether it's blobs or normal transactions is actually the same story. It's just that blobs are more like bandwidth consuming. So you might be tempted to exclude them more than like normal transactions that don't add much. It's exactly the same principle. It's like, okay, can I wait a bit longer, hoping some valuable transactions will come in, and then send like smaller blocks so they can actually propagate quickly through the network and everyone can see it and it will be attested on. So that's like the kind of trade-off some people might be tempted to play with. And that's where censorship resistance for economic reasons comes in. Is like we want people to be like, we saw these transactions, whether these are like normal or block transactions, so you have to include it. And otherwise your block won't be valid, but I'll get into that when talking about inclusion lists. I think it's a very good example of like why you might be tempted to not include some transactions for economic reasons.
I agree there should be look into some research to prevent those behavior. But I think we're also approaching a state where now blobs are almost in every block or close to. We're close to the 3 blobs target per block. It doesn't seem like a big issue, but it is worth like keeping an eye on, I guess, and making sure nothing bad ever happens and it never goes too far to the wrong side of the.
So I guess like to talk about censorship resistance, we must know what are the data we are looking at. To review the numbers, I actually have a chart crime. So this website, mevwatch.info, I believe it was the first one came out when OFAC becomes such a concerned topic. And I think it was useful for a bit until people realized there's a lot of like nuances that kind of makes this thing doesn't really stand, which is, so basically this website is trying to show like across all the relays specifically, how many of them are censoring or basically checking if there's OFAC transactions, and they will throw it out. And so they would show this timeline charts where it looks pretty bad, really bad. Like for, I guess, like Ethereum, where you would see like the when the red goes above like 80% and this is when MEV Boost just launched. And I think it was like getting reported whenever it goes beyond over 50%. This was in August 2023. And I believe also you might have stopped updating because MEV Boost must have a higher percentage than what it's showing here. A few things I have problems with for this website. One is if you read through their methodology, it's pretty much saying that the way they're labeling the censorship percentage is by just checking for different relay entity, which is like around 6 or 7, if they are censoring or not, based on like public statement or whatever information you can gather. It's not really checking on a block or a transaction level if the transactions are really being thrown out. So they actually have a caveat here. Is like not all the blocks built by OFAC compliant relay are censoring. However, all blocks built by OFAC relay will censor with non-compliant transactions broadcast to the network. So really, this is just like approximation based on the labels. And another thing is that it's emphasizing pretty much only on the relay end until you would realize actually it's a whole. If we review the MEV supply chain, there's builder first who actually construct the block. They are the first one who have the right to censor transactions. If the block they submitted to relay doesn't have any transaction they want to include, it's already censored. Then like the relay doesn't even need to do anything about it. So Tony from EF, who is another, I believe, a wizard and a researcher at EF, he has produced a lot of like nice data websites for PBS topics. The famous one including mevboost.pix. He started this website called censorship.pix. He actually has a series of websites which you can find on pix.info. Right. And so here he listed out actually more parties where if you look at builders, the censoring level is quite low. If you look at relays, the censoring is slightly higher because of mostly OFAC. And on the validator side, it's around 11%. It's like lower as well. And he also, had the methodology here specifying that like he's looking at the entities' blocks specifically on chain and see if they have a low percent of including the transaction. So this is like a much more practical way of like actually labeling the data rather than just saying, oh, they said they are going to censor, then I'm going to label it as censoring. And also mention a different layer of like censorship that's happening. And one thing to mention also, like when you look at different entities that's different from relay, builders have other reasons to censor, not just only OFAC. For relay, mostly because if they're operating in US, they have to be US compliant. And so they have to like do the OFAC censorship mostly. But for builder, it's possible they can censor out of their economic incentive if they see potentially competing searcher builders sextex flow, they may not include it and include their own competing flow. Once you look at multiple layers, you would see a lot more issues rather than just OFAC. So I guess like to conclude, what's the current level of censorship resistance? It seemed like on the builder side, we're pretty good right now. Although there actually also is a big drop. I believe this might be Beaver switching to non-censoring. If anyone else have more info on this.
Yeah, that's it. It's one of the big dominant builders stopped censoring.
Right. And then validator seems to fairly low. And then for relay, it seemed like around like 50%, just because where they are resided in terms of US or not. Cool. So I think we reviewed on the current state of CR as well. The question next is like, what's next? What can we do to really like improve censorship resistance? For this part, I think Thomas have a shorter presentation that can share with us about the current proposals that's being considered in the community. So if you want to share, feel free to start.
Okay, so about the data, MEV Watch was also kind of not updated for a while, so I think that also plays into it. And maybe just like a more general comment on like how hard it is to qualify someone as censoring or not. Is like even if you have like a list of addresses or transactions that are supposed to be censored, like you still have to use heuristics to say what is the delay after which I'm considering this transaction was actually censored, which is not like something, there is no hard truth. Like it's is it like 2 blocks, 3 blocks? Like is it more like it's kind of you have to use some approximations and some heuristics there anyways. But I think like Tony's dashboard gives a very good picture of all.
It's a similar problem to like reorgs and change finality, I guess, where at which point you consider the change final, and how big could reorgs be, and like you never really have a final answer, but you have like good approximates based on history.
Well, no, I mean after the reorg ends, you do have like a number of blocks for which it was reorg, but yes, like when it's going on, yes, you don't really know, and what you consider a reorg based on heuristics like ex ante is, yes, it is difficult. You have to look at it like ex post and see like was it a reorg or not. Yeah, I completely agree. So yeah, I'm going to talk a bit about some context and some of the work we have been doing on inclusion lists. And you guys are like, yeah, very familiar with ePBS and PBS by now in general, I think, because of the series. And I saw you guys had an episode with Burak about this, so I won't like spend too much time, but it is motivated by PBS, I guess. So yeah. Proposer builder separation was kind of introduced at the same time as the merge, and the idea was very, very simple. It's like we know there is MEV, and we also know like you kind of need to use sophisticated strategies to extract some value when you want to reorder transactions within a block. And we don't really want validators or proposers to be sophisticated, because then you create this kind of economies of scale of like the sophisticated validators will get more MEV, and they can get more sophisticated or even like spin up new validators. And then with economies of scale, they will just like the validator set will just become more and more centralized, which we really don't want for a lot of reasons, including censorship resistance. So the idea was like, okay, we shield the validator set from this kind of centralizing force. And instead, we have this other class of actors that are called builders that we know is going to be more sophisticated and more centralized. But that's fine, because basically what they will do is compete between them in an auction to propose to like build the most valuable blocks. And then the proposers can stay decentralized, because all they will have to do is just select the highest bid, which is like the highest value block. And that will determine the winner of the auction amongst builders. But they can stay decentralized because that's very easy for them to do. And builders will be more centralized and more sophisticated, but that's fine because they are not the actual validator set. And so that actually worked out quite well, like because validators on Ethereum today are like quite decentralized. There are lots of nodes and they are like all across the world, so it's pretty good. But what happened with builders is they actually got very, very centralized and very sophisticated. So now we have like 2 builders building 80% of all blocks, basically. So that's not great because the barriers of entry are like really hard for other builders to come in, and so we have done some work on it with Danning actually and Burak as well. But basically what it means is like we rely on 2 parties basically to uphold like the censorship resistance properties of the network, which we definitely don't want, because if those 2 parties like decide they want to censor some kind of transactions for any reason tomorrow, then 80% of the blocks will be made by censoring entities, which we again don't want. And yeah, so in the data, it's also from Tony's dashboard, you can see that the impact of just one of the very dominant builders that stopped censoring around July was huge. Like it went from basically like 65% of blocks that are censored or like made by censoring builders from like under 20%. So it's good now because like there is not a lot of censorship, you can say, but like how dependent you are on like so few entities is not desirable at all. So yeah, inclusion list is very, very easy as an idea. It's like you allow validators or proposers to specify a list of transactions that builders have to include in their blocks. So they will build their blocks as usual, but then they will have to include some transactions other parties decided on in their blocks for it to be valid. Like otherwise, like they can propose the block and everything, but attesters just won't vote for it, and it won't become canonical. So that's like the very basic idea. It's very easy to understand. Also didn't mention, but like feel free to interrupt me anytime if you have questions. And then you can, okay, so this is very simple, but it brings like a lot of different questions about like what are the properties of these inclusion lists. So the first one can be, okay, where does the builder have to include these transactions from the inclusion list? Does it have to do it like at the top of the block, at the end of the block, anywhere? Like it doesn't matter. So we have to specify this, and it actually has like a lot of consequences because let's say we say top of block, that's also where people are like competing to get their valuable transactions in, like arbitrages and yeah, other sorts of very valuable transactions. So we don't really want this because that means the inclusion list will probably be crowded by transactions that are valuable. An inclusion list is supposed to be like for censorship resistance. So we expect like transactions, pending in the public mempool. We don't really want like the space in the inclusion list to be taken by like MEV transactions. So that's one property. You can also say, okay, do the transactions from the IL need to go in the same kind of, do they need to share block space with other like payload transactions, which is what we call conditional, or do they get like dedicated block space? So they are like a completely different mini block basically. And in that case, it's also interesting because if you make it like a different block, intuitively you are like, oh, it's great, like they have guaranteed space, but like you can also expect like people will do exactly the same with regular blocks and kind of outsource them and try to have like the most valuable inclusion list built, and then like it also defeats the purpose of censorship resistance. So you have to be quite careful about all this. Then you have spot versus forward. Like, okay, so there was a design that was called forward inclusion lists. That was worked on a lot by Mike, but also Francesco, like a lot of people I work with at DEF. And yeah, by the way, inclusion lists have been worked on for like a while. Like Francesco and Vitalik wrote about this more than 2 years ago now, so it's been a little while. But yeah, forward inclusion list. So that proposal was actually considered for inclusion in a fork, and then got rejected for several reasons, but incompatibilities or like equivocation possibilities or stuff like this. I can get into it later if you want. But forward inclusion list is like one proposer of slot n-1 makes a list, and that list constrains the next proposer. So for slot n. It's very easy. It's like one actor makes a list for another actor that comes next, and it keeps going. So you don't make the list for yourself, which doesn't really make sense. But you make the list for the next proposer, and that was called forward inclusion list, and that was actually considered for inclusion in a Ethereum fork. But you can also have like spot or same slot inclusion list. So because forward inclusion lists have like this kind of delay of, by definition, delay of one slot. You can also say, okay, the payload and the ILs are built at the same time, like in parallel, and then the IL is released a bit before like the block proposer or producer or like the builder has to release its block, so we can include those transactions in its payload before it actually gets to propose. So those are like same slot or spot inclusion lists. And then you have who's making the list. You have like a single entity, like in the forward design, or do you have multiple parties? Multiple parties is intuitively a lot better, because now if you want to censor one transaction, you have to bribe every single member of that committee to censor it. Whereas single proposer, you can actually just bribe the one guy and censor the transaction if you want to. And then, yeah, you have questions like who's checking that transactions from the list were actually included in the payload. For us, it's usually attesters. They will just consider the block not valid if it doesn't satisfy the requirements of the inclusion list. And if you have multiple validators making inclusion lists, how do you actually like merge these different transactions from different lists together? And then you have like different approaches. Usually you do like some kind of union across all the inclusion lists. So you have like a final kind of set of transactions, but then who decides what's that set? And then who, like, does anyone have the right to reorder these transactions too and include it in the payload? So all these questions are quite interesting, but like they have a lot of different consequences that you need to think of. So you have different proposals. We have been working on one in particular that I can present later, which is fossil. So it's basically an inclusion list proposal, but with multiple IL proposals. So if we go through all the properties, conditional inclusion list, so it's shared block space. Transactions can be included anywhere in block. And so these two properties, like conditional and anywhere in block, is like basically you don't impose too many constraints on the builder, because otherwise he will be very tempted to just buy some bribe IL committee members, or like even try to become one IL committee member and like try to kind of take advantage of the fact that there is an IL committee to go around those constraints. So there is still like one builder or one proposer that can rearrange the transactions as he wants, but as long as he includes them. So like that's a property that's actually enforced. It's enforced by attesters of the next lot. And it is built concurrently, so it's in parallel as the block, so it doesn't like suffer an extra delay. It's kind of real-time censorship resistance. You can definitely go more into it if you want, but that's like the core idea. And we want to, I mean, the work I'm doing right now with other folks, of course, is to try to push this and open an EP for this, so we can actually propose it for inclusion in one of the next upgrades. And we have, next steps, fossil for blobs. We discussed a bit about this. We have to see whether it's compatible with like other upgrades or proposed upgrades like PBS, PBS, account abstraction. Whether we want to incentivize IA committee members so to include some sort of transactions is also like a very interesting research question. For now, we are like not incentivizing them. It's basically altruistic behavior. And yeah, we are still exploring a lot of different things, like how do ILs actually interact with APS or PBS, multi-block MEV. I talked about this, but how much do we want to constrain builders? Is there like last loop problem? Like, is it an actual problem that there is still one party that can reorder the transactions after, like, as long as he includes the transactions from the IL? And then I've been also working on something cool that's further down the road probably, but anonymous ILs. Like, can we hide the identity of people that are submitting the ILs so they don't expose their preferences or like the transactions they actually want to include in their lists?
Thomas, so in this fossil model that you guys are proposing, can you walk us through like one concrete example of like how would it look like if I want to deposit my money into Tornado, like Like how would this transaction actually kind of flow through the transaction pipeline? And how would we ensure that it actually ends up in the block? Can you draw an example like that?
Yeah, for sure. That's a good way to think about it. So you have your transaction. That transaction will be pending in the public mempool, and so everyone can see it basically. And then you have a committee of, let's say, 16 parties, but it can be more. That's implementation details, and they are all going to see that transaction pending. And you only need one of them to include that transaction in its list for it to be constraining the builder of this slot. So it's a 1 out of n property. It's pretty nice because you only need one party to actually see the transaction and decide, okay, I want that transaction to be included because I saw it and it's pending in the mempool, to be part of the inclusion list. And then the inclusion list has to be satisfied by the block builder or proposer, like anyone who is actually building the block, for its block to be valid. So that's kind of what's nice about this is like, okay, imagine you don't want that transaction to make it at all. Then you have to go to all 16 members and say like, please, I need to give you money. So you don't actually include that transaction in your list. Because I really don't want it to go on-chain. So that makes it like a lot harder, right? And that's like the basic idea.
Well, on which basis would the committee pick transactions from a public mempool? Would it just be like time constrained, like this has been in here for 40 minutes, maybe we should give this a go, or like what's the mechanism?
Yeah, that's a super good question. I think so the first idea was very by default, like order by priority fees, just like do a dumb ordering like this. But we actually want to encourage like many different rules. So there could be one that orders by priority fees, another one by time pending in the mempool. So we can, like, by having these different rules, we can actually make it much harder for anyone to try and game the thing, because everyone will have like different criteria. So it's actually valuable to have different strategies. But yeah, I mean, the very simple dumb example is just like very basic ordering by priority fees, but you can also think of various other strategies. And I'm sure like clients will, implement some of them. Again, like those are not supposed to be valuable transactions. So like, it's nice because you can just like take these transactions and include the ones you think is going to help the network the most. You probably won't benefit from it, but it is like some kind of a very important part of what you're doing as a validator.
Yeah, and you're saying this committee that would kind of make sure that the transactions actually land in the block, they would do this as an altruistic function for the network. So like, who do you actually like? Is this just something like MEV Boost, where every validator is, or like every altruistically motivated validator can just also kind of run this module, or like how do you imagine that like kind of logistical implementation of this function to work?
So that's in protocol. That's like the validator by default. So MevBoost is still like a sidecar, right? Like you can opt in or not, but it's not in protocol. It's still out of protocol PBS. This will be like part of the actual Ethereum protocol that you have to run. So it's like, it wouldn't be like opt-in or optional. Of course, you can try to modify your client or like do all sorts of things. But like it would be enforced by default, basically. And then the altruistic part is like very interesting. I think we were thinking of like mechanisms to reward validators. For example, you can say, okay, we want transactions that are like not included by a lot of people to be included more than others, because maybe those are like the censorable ones. So you can share the fees for a given transaction across the members that include it. So if you are like the only one to include it, you get all the fees. But if everyone includes it, it's like split into like 16. And you can like think of stuff like this. But like the reason why we didn't implement it yet is because it actually gets very tricky when there is congestion. So when blocks get full, and then like you can get into like super weird cases where if fees go to IL committee members and not to builders, then you, as a builder, you might be incentivized to include transactions that are paying lower fees, but because you know these fees won't get to you in the first place. So it gets like very tricky, and we are like still researching it actively. But it's a very nice topic. We also think it might just work. Like people in the network are like usually like acting honestly. That's what we rely on. Like if we don't have like an honest majority, then everything kind of crumbles. But so yeah, the first version will be like without rewards, but we are like researching it super actively to see, but it's also like an interesting question in itself.
The altruistic part is very interesting, the one of n model, but then like it also has me thinking maybe there's a tipping point where there's more incentives to be bribed than to actually be to be altruistic, and everyone kind of colludes with the block builders again, and we're right back to the problem we had in the first place. So yeah, how would you envision preventing that from happening?
Yeah, so I mean, yeah, if all 16 committee members collude and there is not one of them that is actually willing to act honestly, then it falls apart. But like one of them is like one of the strongest guarantees you can have. Like it's not a majority assumption, it's not 2/3, so I think it's pretty good. But yeah, I think like one way to prevent this will be to actually have rewards. So it tries to like compensate for the fact that you can actually bribe or like use MEV boost kind of things. The only thing that's very important, the other thing that's very important to say is like there is no incentive to try to get your transaction in a block via the IL compared to just like submitting into the builder. So it's like there is no real incentive for people to bribe IL committee members to include their transactions, because since the block builder still can reorder transactions, and if the block is full, he can include like the transactions he wants. Like there is basically this, like if you want your transaction to get in, you just need to submit it via the public mempool, and that will get you good guarantees that it will be included.
Yeah, that's true as long as the ordering is by priority fee, right? Otherwise, I could kind of get cheap transactions into blocks. Like if we're in a period where block space is very kind of sought after, and I would usually have to pay a high priority fee to just get into the block at all, then if we were to do this time thing of like, hey, this has been sitting here for 40 minutes, then I could maybe get a slightly cheaper transaction into it. But as long as you order by priority fees, it would kind of, and like the circumstances for that to be true are like very, very, very rare in the real world, but just game theoretically, if you sort by priority fees, then that would hold true.
Yeah, no, that's right. And I think the congestion part is like very, it's like something we have to like be very careful of because it happens. Like sometimes blocks get congested, and that's when you want to make sure like you give like enough kind of freedom to the builder so that it still has like the liberty of including his transactions in priority if he wants to. Otherwise, like it gets very messy, and you very rapidly have a competition between the IL and the block space, the normal block space, which again you don't really want, because if there is an opportunity to crowd that IL with like MEV transactions or transactions you think are more valuable, people are going to take it. So that's one of the very core design philosophies behind it.
And the block builders can see the transaction details that are included in DIL, right?
Yes.
They have full vision. Okay, yeah. Okay.
Yeah. And the only rule is like you have to include it for your block to be valid, as long as the block is not full. And that's basically it. And what's cool is like, I mean, the proposer or the block builder obviously can see the transactions, but so can everyone else. And that's how the attesters are like, we also saw it, so he needs to include it. That's kind of like the mechanism here. Like you compare the views of everyone, and like every attester is checking, he must have seen this and he didn't include it, so I'm not going to vote for his block. Or like, okay, like we have the same view of everything, and the proposer or the builder actually included every transaction I saw too, So that's good. And he included it like in its payload. So it's good.
Would you get slashed maybe, or what are the penalties for not including inclusion list?
Your block just doesn't make it. Like attesters don't vote for it, so it never becomes canonical. So
yeah.
But like also like I still don't know like how you define a full block, because there's always could be more transaction pending rather than the block space allow. And so you see the Tornado Cash transaction in the mempool doesn't mean it needs to be included if you have like say priority ordering rule, right? And so it sounds like the validators needs to also even run like a block simulation algorithm to know, okay, by priority. It's like, how can you define that transaction was supposed to be included in this full block size?
Yeah. So the IL proposers, or like the members of the committee, actually send out their list of transactions. So like it's very, very clear like what transactions need to be included. Like 16 people, they make their own local list of transactions. They all send it, and the proposer has to include the union of all these transactions. So it's it's not just like a mempool thing or like everyone. No, it's like very clear the set of transactions that needs to be included by the proposer.
Okay, but then you also said like the builder has the last look, so they can decide to not to, or they can decide.
No, they have to include every transaction. They can reorder them. Like the set of transactions is fixed and it's very clear. They have to include them, but they can include them anywhere in the block. Like there is no restriction on ordering in Fossor. And then they have to include it if the block is not full. So if the block is at capacity and 30 million gas, then you can leave some transactions out from the IL and not be penalized. Like that's like the only condition in which you can like not include some transactions, but otherwise you have to include every transaction that is part of the set.
Does it matter how much the inclusion list transaction pay? Because so that I can exploit the inclusion list by just like sending zero gas fee kind of Tornado Cash transaction whenever I need to do transfer, and I will be included for sure.
I mean, if it's zero gas and it's mostly ordered by priority fee, then you might not be included very rapidly. The idea is like, yes, hopefully you will get included at some point, because we do want like everyone to be included, and priority fee is not a determining factor of whether you get included or not. It's like as long as you pay the base fee, then you are included. You are supposed to be included. And if I mean one of the rules is to order by priority fees, then if you pay zero fee, yes, you might not be included because other transactions will be in the list and you won't, just because people have decided to order by priority fee.
Okay, so like the committee needs to have some kind of like either ordering algorithm or deciding, okay, this transaction in the inclusion list must be included in the next block, or you might be included later. Like they will have to have some decision on that. Like to check against the builder.
Yeah, the committee is responsible for making the list in the first place. What's also kind of nice is like every 12 seconds there is a new committee. So those are like randomly chosen validators. So, if like that committee by any chance is like malicious or whatever, there's a whole new set of people that is actually responsible for including transactions in the next block. So that's also like kind of nice. It's like a refresh.
And I'm curious why it's 16. Is that a number calculated based on like the number of total validators, etc.?
No, it's more like so what inclusion lists mostly consume is bandwidth, because you have to like get these lists of transactions across proposers and everything. And so it was like, how many transactions do we want in? What is a kind of size of objects we are comfortable like passing through the network? So 16 is like 8 kilobytes per inclusion list. And yeah, so you get like mostly around like one blob worth of data of bandwidth when you actually get all these objects together, which is fine. So that was mostly like sort of the calculation here. It can be changed, like when devs or clients like actually experiment with it, and like maybe it can be turned up or down. But like it was a brief calculation we made, so we can have like as many transactions as possible and as many proposals as possible without actually like being a huge cost to the network in terms of bandwidth.
When could we expect this EIP to be available? Do you have some like ETAs maybe?
Yeah, very soon. Like I would say like before DevCon is the kind of order of ideas. So it should be very soon. If it's a bit later, like don't quote me on this, but it's gonna be very soon. Yeah.
Okay. Cool.
Wait, that's the EIP being kind of published and then like it's
open.
Not the fork that actually.
No. Yeah. It's opening the EIP. No. That's a longer process.
Yeah, I think we were all excited for a second there. If I look at the faces of Dag and Dobby, we're both like, oh, what the hell? But okay. What's the like? That's like another year, or like what do you figure?
I mean, that's not really up to me after this point. It's more about like what the community decides and like if devs and people are excited generally, and then it's all about like trying. Everyone thinks there are like a lot of upgrades and they're all important. So it's a matter of like how much of a priority people think this is. I do hope there will be quite a good turn up and like people will get excited because it's something that has been discussed and again. And there was a previous proposal that was like rejected for like technical things, but like that was still like generally agreed upon, and this one is I think strictly better. So yeah, I think there's a good chance.
Nice. And I'm curious, like there were many like ePBS related things were being proposed. And I'm curious, what are the next thing after inclusion list if they can be shipped?
Generally, like
I guess like
range of things.
Right.
But EPBS is like an EIP and it's open. Like it's actually an open EIP and it's up for discussion. And Potus and Terence have been very active on this. Terence has also helped a lot with the specs on Fossil. Yeah, I think like one fun thing is also to see how the next upgrades can be compatible with each other. So we've been working with like people working on adjacent things or like things we think might be included to see like what are the synergies? Can we actually combine stuff, make it a bit cleaner, or like do they work together? And those include EPBS, account abstraction, APS proposals, all of this, PRDAS, data availability.
I guess last a few questions to just curious about your general comments of like the current development among the ecosystem. Like I feel like this year, the recent year, the hot topic has been like pre-confirmation. There was launch of commit boost, and then it was like based rollup, shared sequencing among L2, eigenlayer as restaking service, and rollup boost recently with Unichain. I'm curious. I'm just throwing a bunch of words here, but I'm curious, like among all these like development in the community of Ethereum ecosystem, are any of these things are like obviously conflicting with like CR or like are compatible or like raising concern about CR? Yeah.
Yeah, I mean, there was a lot of different things. So let's go with I think like all the proposals that potentially centralize or act as a centralizing force to the validator set are somewhat a threat, like because more centralized validator set means like the kind of thing we rely on right now with Fossil and inclusion list, like we are taking people from this decentralized like validator set to actually have a say and constrain the more like sophisticated builders. If the validators in the first place actually get more centralized, then I mean the whole thing falls apart. So it's kind of very important, I think, to really make sure like validators are like keep like acting as like a kind of a dumb pipe, or like we don't ask too much from them. There are some like cool nuances we can make. Like at the end of the day, even like proposal, like block proposal, like or execution proposal, might be okay to actually give to a more sophisticated set of actors. What we really want to protect is attesting. So the attestation part of and the proposal part are like very different parts, and now they are all bundled up. Like validators do everything, but you can also think of like ways to that's kind of APS. It's called attester proposer separation to like shield kind of the same idea, but like shield attesters from centralizing forces that might come and that are very specific to block proposal. So it's like kind of remove even further the attester part of the pipeline, so they stay completely decentralized. And so maybe the proposer can be a bit more centralized, but that will be fine because the actual important part of like everyone coming to consensus to say whether like the chain, the block was valid and we all agree on something will be still decentralized and unsophisticated.
Once you're done with this EIP and it's mostly out of your hands, what are you excited about working on next? Is there any specific topic you're interested in terms of protocol research or anything you want to dive into?
Yeah, so right now I'm really deep into this, so I'm like trying to focus a bit. I also think like all the kind of extensions are kind of cool. Like fossil for blobs is like a very obvious thing to work on. The reward mechanism is also like something I'm interested in. So like things like that, like anonymous inclusion list are like super cool. I collaborated with the EF cryptography, and that was like extremely nice to learn some new things. And I think the idea of like protecting the identity of the set of participants can be also like very valuable for inclusion lists. So stuff like this, I think I'm kind of excited about. I think the more general I think we are at a stage where we have like a cool idea of different components, and now it's all about trying to make it work together to get to like this kind of global picture of how the network will work with all these new cool features added. Now we are like, okay, we have an idea about this, we have an idea about DAS, we have an idea about maybe PBS. Like, how do we actually make it fit together? So it's not just like, it doesn't look like a bunch of features added together, but like more of a coherent picture of like what does the actually like high level picture look like is something I'm very excited about. And then in our group, we have a bunch of people. So Gaspar and Anders mostly are working on issuance. That's been like another very big topic, and we have to get moving on this too. So that's very top of mind as well. APS, and then I also like, so Barnabe had a post about rainbow staking, which is like, what is the role of future of staking? Can you have like different tiers of stakers? How would that work? I think that's also very interesting. That would allow, validate some validators to do some tasks and some others to do others, and those sets to have very different properties based on what we actually want. Like, is it economic security? Is it censorship resistance? Those can be actually like different sets of people. So this is also like a cool thing we are working on. And PRDAS is also something I'm getting into now, because I'm getting into it, like trying to understand how it fits with Fossil. But it's also like super cool to look how this evolves and how we can actually scale like blobs by a large factor.
I guess you already touched upon my question that I'm gonna ask, but like, yeah, you mentioned like there's many projects going on, but I'm curious, like, what is the future of Ethereum look like? I guess like the big question, or like Ethereum 3.0, or like from outside, we know that the EF is committed to, or like Ethereum is committed to a roadmap where like home staking is the future, and I think in the past we kind of chose L2 as the sharding or scaling solution, but like recently there has been debates and like people are saying, oh, L2 is broken because it's not incentive aligned with Ethereum once they have a token themselves, etc. And Justin is busy debating like Solana people, and then people are like, yeah, we need the high performance for Ethereum as well. We need a big block, faster block time. So I'm curious, like, what's the take from EF side on this, or like, what's the actual, like, the one big thing that you guys think is originally to be solved?
Yeah, so I no take from the EF side, but a personal take, because I like, it's actually like very, very true that everyone has very different opinions, even within the OF, like the EF. I would maybe like sit on one of the extremes. Like I think scaling is cool, but you have a lot of centralized systems that work really well and that scale like crazy. So you can use these if you want. I think what we have with Ethereum is extremely valuable, which is like solo staker and an actual decentralized set of validators, and that everyone can run a validator at home. I think it's like something like not a lot of networks have, and that's actually very valuable. So for me, like the main value of Ethereum resides in its ability to keep scaling while maintaining these properties. And it's the challenge, because every time you see a cool new efficient scaling solution, you might be tempted to go for it. And then you look at it a bit more and you're like, wait, okay, then it means no solo stakers, right? Because there is no way people can actually afford all over the world to run a box to like meet these requirements. So like, and for me, yeah, I do think there are very different opinions on this, but like for me, I would rather like keep the solo stakers and scale a bit less than go full on scaling and lose this kind of property. Also, like it's very differentiating. It's very unique to Ethereum, I think, and we need to be careful about like preserving this. But again, it's very personal take. Like I think there is value in scaling the L1. There is value in like having more throughput via blobs for sure. I just want to make sure we don't lose like something that we acquired along the years, and that is very valuable.
All right, interesting. I think we need a rainbow map of solo stakers to differentiate them, because I think that's where a lot of the contention actually, or like it feels like on my timeline that's where a lot of the contention lies, which is like, should you be able to run this on like an Arduino on like a PC from 2005, or should we actually kind of like, can you say people should have a modern kind of gaming PC or something, and that's the requirement. But that's a whole other episode. When that topic becomes relevant, we might have you on if you pivot to that after this. We'll see. But yeah, I think this was a super interesting conversation about censorship resistance. Thanks for sharing your thoughts and your work on this. As a citizen of the Ethereum ecosystem, I am thankful. Good luck getting this EIP to the final stage, or actually into the network. Probably really exciting for you. Will be the first EIP that you worked on that would make it to mainnet eventually, right?
Yeah.
All right. Certainly exciting. Not many people can write that on their resume. But yeah, thank you so much for coming on, Thomas. You have listened to the Index podcast. Tell all your friends about this. And I think we'll see most of you in Bangkok. All right, everyone. Bye-bye.
Thanks a lot, guys. It was super nice.
Thank you.
Bye-bye.
Crypto data wasters, come join us for the parade. From Bitcoin ETF to Solana meme coin trade, uncovering public secrets in the blockchain shade. Bad chiller, cherry picking liar, we call them out and set chart crime on fire.